So students, we start a new chapter today, probability. Now you have already studied few things about probability which I would like to revise now. So let us start with a classic example of tossing a coin. So let us toss a coin. Now when tossing a coin I can get either a head or a tail. Now I got a head. Now if I toss a coin again, let us see what I get. I get a tail. So while tossing a coin, I can either get a head or a tail. Now, head I can call it H and tail I can call it T just to make it short. Now, there's a 50% chance of both happening. We cannot say, oh, it can be head. We cannot say, oh, it can be tail. It's a 50-50 chance of anything happening. Now, so we have a scale from 0 to 100, and our probability goes between these values. When we say 0%, we say it is not going to happen. When we say it's 100%, we say obviously, surely it will happen. That is how we use in a normal speech. Oh man, I'm 100% sure means it's like you're almost correct. And when you say no man, there's 0% chance of me going there, means you are not planning to go there. So that is how we usually use these terms in a normal language. But here in heads toss, in the case of tossing a coin, it is 50%. So let us put that into the center. Yeah, 50%, which just means that you don't know. It could be heads or it could be tails. You have no idea what it can be. Okay. Now it is okay to put it in a scale between 0 and 100, where 100 means yes, 100% sure, sorry, sure. 0 means almost impossible, almost. But we have another range of values which is most commonly used, which is we divide the scale by 100. So we get another scale with where the values range from 100 divided by 100, which is 1, and 0 divided by 100, which is 0, and 50. So 50 divided by 100 is almost of course 0.5. Now, so we have a value, we have a scale which ranges from 0 to 1. Do you see that? Which is the same scale. That 0 to 100 and 0 to 1 is same. It is just you're dividing it by 100. You're just scaling it down. It's the same thing, because when you say the probability is 100% sure, we say the probability is 1. P is equal to 1. We have already studied this previously. So P is equal to 1, which means 100% sure, and it is going to happen. And when we say something is obviously not going to happen, we say P is equal to 0, or probability is equal to 0, which is equivalent to 0%. And so in our case of tossing a coin, we get around 0.5. So this is the values that we usually use in probability, and the values range from 0 to 1. Okay, let us make that clear in our mind, which is not a different scale. It is the same thing corresponding to 0% and 100%. So these are all different ways to represent it. Okay. Now, what if we toss two coins? What happens when we toss two coins? So what are all the probabilities that can happen when we toss two coins? So in this case, when I toss two coins, I get a head and a head. And what all can happen? Now I get a head and a tail. Now I get a tail and a head. Now I get a tail and a tail. So what do you see, students? What do you see? So when we toss two coins, there are different ways of getting them, and we have to do it simultaneously, which I could not do it because I'm doing it on the computer. So as having only one computer, it is difficult for me to do that. But you can just imagine it to be done simultaneously. Simultaneously means to doing it together, tossing two coins together. So you have four possibilities. You can get a head and a head. You can get head and tails. You can get tails and head. You can also get tails and tails. Now let us put them as in a set. We studied sets in the first chapter, sets. Let us put them in curved braces, flower brackets, which makes it a set. So this is our set, and in this set we have all the possibilities that can happen. There is nothing beyond this that can happen. I mean, you can either get a heads or heads and tails, or tails and heads, or tails and tails. There is no other possibility. These are the only four possibilities. So we call this thing, or this set, we call this set, what is set? A collection of items. This set, which is a collection of possibilities, is called sample space. Okay, and to make it short, we call it S usually. So S, or sample space, is a collection, or the mathematical way of saying it, it is a set of the possibilities that can happen. In our case, now it is tossing a coin. So tossing two coins together. So tossing two coins together, you get four possibilities, that is a heads and a heads, heads and a tails, tails and a heads, and then tails and tails. Okay, now let us check the probability of each one of them. For that, let me just take off the coins. Now let us focus on this. What is the probability of getting same side or same sides? And P of same side means what is the probability? P refers to probability. Probability of getting the same side, what is it? For that, we can say these are the options that we can get. These are the only two cases where there's the same side coming up. Now for that, for probability is, as all of you know already, probability is represented as a fraction, where the maximum value is 1 and the minimum value is 0. We already saw that. Now between 0 and 1, the probability is represented as a fraction, and the denominator is always the number of possibilities. What is the number of possibilities? Number of possibilities is 1 is HH, 2 is HT, 3 is TH, 4 is TT. So there are 4 possibilities. So denominator is number of possibilities, and the numerator, what we do is, what is the possibility of the given case. The given case is same side. The same side, there are only 1 and there are 2. So the numerator is 2. So this is our probability, 2 by 4, which is, of course, we know 2 by 4, when you divide it, we get 1 divided by 2. So 1 divided by 2, 50% chance. Okay, so there's a 50% chance, so there is 1 by 2 of the probability value is 1 by 2 of getting the same side. Now what is the probability of getting different sides? Again, the denominator is of course 4, because that is, the 4 remains same, because it is the number of total possibilities of the sample space. Or when you toss two coins, what are the number of all the possibilities is the denominator. That never changes. At least in our what we study this year, it doesn't change. There is a type of probability in which it does change, which we are not studying in this year, which God willing you will study in class 12th. And that's a very interesting case, but for to understand that we need the basics of what we studied this year. So let us focus on what we study now. So the denominator remains the same, and what happens in numerator? The probability of getting different sides. So let us, it becomes ht and th. How many cases are there? There are 1 and 2 cases. So the numerator becomes 2, which again, when we divide it or simplify it, we get 1 divided by 2. Again, a 50% chance of getting different sides. Fine. Now, what is the probability of getting head? They are not talking about 2 heads. Probability of getting a head, only 1 head. So, what is the probability of getting a head? Now, if we look carefully at our sample space, we can see that the denominator is of course 4, by the way, it never changes. What happens in numerator? What are the probabilities of getting a head? There is an HH, here you get a head, here you get a head, because they're not talking about heads. They're not talking about completely getting heads on both the coins. They're talking about a head. So you have a head here, you get a head here, you get a head here also. So there are 3 possibilities of getting a head. So numerator becomes 3, and you cannot simplify that in a simple way. So let us leave that fraction as such, 3 by 4. Now, what is the probability of getting either head or tail? Getting either head or tail. Now students, if you think carefully, you will come to know that is the sample space, because either head or tail means you have everything covered. Denominator is of course 4, denominator doesn't change. The numerator is everything, because in every possibility, HH, HT, TH or TT, you get either head or tail. you cannot get anything else. So the numerator is 4. 4 by 4 is, as we know, if you simplify them, we will get 1. And what does 1 means? It is absolutely sure. You're completely sure that you're gonna get it. And that is of course the same, because whenever you toss 2 coins, you will either get a head or a tail. Heads or tails, or tails or tails, whatever it is, you will get either heads or tails. You are not going to get anything else. Okay, now one more thing. What is the probability of getting neither head nor tail? That means the probability of not getting any head or any tail. You're not getting anything. Now the denominator doesn't change. The number of all the possibilities is 4 itself. But what is the possibility of getting neither head nor tail? When you toss a coin, you have to get either head or tail. So there is no way that you cannot get a head or tail. So the numerator becomes 0, and 0 by 4 is, of course, it is equal to 0. So what do you see? The probability is 0, which means there is no way. There is no, way that you're not going to get head or tail. Okay. Now we saw all these things. Now I want you to look carefully, and you see there we saw about same side, different sides, head, either head or tail, neither head or tail, all these things. What are these things? These things are called in mathematics event. All these are different event, and events are something that you choose, or in our case what the person who makes the question paper chooses. But event is something that we choose. Okay, event is not all the possibilities when you toss a coin or 2 coins. It is what we choose. Suppose I say, okay, what is the probability of same side? That same side is the event, or different side is the event, or getting at least 1 head. That is an event. So event is something that we are choosing. Okay, out of what we are doing, we are choosing something. We are checking something. We are checking for heads, or checking for tails, or that is in our case. But in a general case, something that we are checking is called event. Then if you let us, and we saw that the sample space, we wrote it as a set, right? A set of all the possibilities. Let us write all these probability also as a set. Everything. Let us also write all these probabilities also as a set. So what happens? The probability of getting same side. What are the so what is the set of getting same side? HH, TT, and we'll put them in brackets, flower brackets, and we get the set. What about different sides? HT, TH, put them in the flower brackets, and we get that set, the set of different sides. Set of head, HH, HT, TH. Set of either head or tail, HH, HT, TH, TT, which is the sample space itself. Neither head or tail, it's an empty space, or you have another notation to use, that is phi. You studied that in the chapter sets. It's a null set, empty set. Okay, because you don't have anything, any possibility of getting not a head or not a tail. Now students, if you look carefully at each of these events, you can say that each of this is a subset of this sample space, right? Look carefully, you can say everything is a subset of, even the null set. Empty set is also a subset. We know that phi is also a subset of the any set, and this is the complete set itself is a subset of itself. So this is also a subset. We studied that also in the chapter sets. So what do we see? All these are subsets. So we can say that these things, the events, are a subset of the sample space. Do you see that? Events, an event, we can for shortening it, we can call it E. So all E's or all events are a subset of the sample space. This is one thing that you have to keep in mind. Okay. So that is all about tossing a coin. The next video we will see about rolling a dice. Okay, so see you guys all in the next video.